Okay. Good morning, students. In last class, we will see what is meant by a signal, classification of signals, and what is meant by a system and classification of systems. Now we should go for main thing in our complete to DSP. First, what is meant by signal processing? As the name indicates, signal processing means it is the mathematical operations which should be performed on the signal to get the information from signal. That means to get the information of signal from the signal, we have to apply some mathematical operations. That entire concept, that entire knowledge are we call as signal processing. Signal processing are two types. One is analog signal processing and the one is digital signal processing. Our subject is generally digital signal processing. First of all, we should see analog signal processing. In nature, all the signals are functions of variables such as time or space are always analog signals. X of t signals are there, not x of n. Such signal may be processed directly by analog systems. Okay, that means in nature all the signals what we have generated all are analog signals. To perform operations on analog signals, we have analog signal processing concepts and analog processors. Such type of signal processing we call as analog signal processing. Here both input and output are in analog form. Input signals are analog signals, output signals are analog signals. But why should we go for digital signal processing, sir? Let's see. This is the black diagram of analog signal processing. We should give analog input as a signal. There is analog signal processor that should perform some operations on analog input signal and produces analog output signal. This is called analog signal processing black diagram. This is the general black diagram and this is generally we have used always. But the problem is whatever the output signal we have, analog output signal, to analyze that signal, whatever we have, systems, mobiles, CROs, all are digital nowadays. That means analog signal cannot operate on digital systems. That's why we have to convert this analog signal into digital signal to perform operations on digital circuits. Nowadays all the circuits are digital circuits. Who use analog circuits? That's why we should go for digital signal processing. But whatever the input we have generated is always analog. That's why we have to convert first analog signal into digital signal, input, analog input signal into digital input signal. That should be given to digital signal processor. That will give digital output signal. That digital output signal directly we should give to system. No problem. There is no A to D conversion is required. A to D means analog to digital. Let's see. Digital signal processing. This is a black diagram of digital signal processing. First we have given analog input signal to A to D converter. A to D converter means analog to digital converter. That should convert analog signal into digital signal. That digital signal given to digital signal processor, which will process on digital signals and produces digital signals and outputs. That digital signal given to D to A converter, that will convert digital output signal to analog output signal. Sir, compared to analog signal processing, digital signal processing circuit is very complex. Whenever it's complex, whenever we require analog output signal, if we require digital output signal, then there is no need of D to A converter. Why we require this one, sir? All the signals are analog, but our systems are digital. How we can do it? To do that one, we have to convert analog signal to digital signal. That's compulsory. That way we require I to D converter. It will convert analog signal to digital signal. Then give it to our circuits, whatever the process we have, Intel, whatever process systems, whatever we have, we should directly given. Then we get direct output that must be shown on screen. There is no need of D to A converter. If for suppose we require that signal on CRO is simply since starting now onwards CRO is analog output signal. That's why we have to convert D to A, again we get analog output signal. Complexity is high in DSP, but all the processors nowadays are digital. That's why we should go for digital signal processing. Okay, simply we should take an analog input signal. We have to convert that one A to D digital by using A to D converter. That digital signal should be given to DSP processor. That should give DSP, that means digital output signal. That should be given to D to A converter. That will give analog output signal. Sir, what is the internal diagram of A to D converter? Let's see. Simply this one is the A to D converter. First we have given analog input signal to sampler. You know that sampling theorem. Sampling theorem convert analog signal to discrete time signal, not digital. That sampler will convert into discrete time signal. That should be given to quantizer to get the quantized signal, that is x cube of n. then that xq of n is given to some coder to get the digital signal. Okay, x of n is the discrete time signal, digital signal is simply zeros and ones. To get that one, we get quantizer and coder. This is the entire black diagram of A to D converter. You already studied in ACS. Same way. Okay. Sampling, conversion of continuous time signal into discrete time signals. You know that sampling theorem. Quantization, converting a discrete time continuous valued signal to discrete time discrete valued signal. And coding, each discrete value is represented by separate codes. So what are the advantages of DSP, sir? Flexibility and reconfigurability. In analog systems, if we design a system, we can't change that internal configuration. If we take a system, it's a 2 GB RAM, initially whenever we buy, then we can change it to 4 GB, 8 GB also, not a problem. That means reconfigurability. We can reconfigurable the system inside, we can change the system architectures. Why? Because digital means always write in a program. If you change the program, it will operate in separate way. Okay. Accuracy, you know that accuracy and reliability is very high in digital. Easy storage, you know that the entire operation should be stored in 1 terabyte the hard disk or 2 terabyte, it's enough, more than enough. Processing is very high and cost effective. Why? Because first digital system, it will take a lot of money, then all digital systems are designed by using systems, no problem. So these are the advantages: flexibility and reconfigurability, accuracy, reliability, easy storage, processing, and cost effective. Disadvantage, you know that if you see the black diagram, circuit complexity is very high. Okay, and the entire operation speed of the operation of DSP depends on A to D converter. How much time it will take to convert analog signal to digital signal. Based on that, DSP speed should be named. Those are the two disadvantages. Applications, in all applications we use DSP kit. Some speech processing, communications, biomedical, consumer electronics, seismology, image processing. All nowadays, all operations should be on digital signal processing operations. That is about what is meant by DSP. It's black diagram, advantages, disadvantages, and applications. And that is the end of first unit. And next class we should go for second unit, that is fast Fourier transform algorithm. Okay, thank you.